The first quarterly payment in a 5-year annuity is going to be paid 3.75 years from now, and that payment size is going to be $850. Based on a rate of 6.25% compounded monthly, what's the present value of the payments today? We're going to break this question down into 2 steps. We're going to deal with the annuity part first. Here, the $850 payment is going to happen at the beginning of the payment period in 3.75 years. Otherwise, this 3.75 would be longer if it was an ordinary annuity. Let's take our interest rate of 6.25% compounded monthly. The payments are quarterly, so let's take PY to be 4. Here we'll assume that the future value is 0. We're trying to calculate that principal amount or present value of the annuity, and the last thing we need is N. This is a 5-year annuity with quarterly payments, so we should be getting 20 payments altogether. So let's go ahead and make sure that we are in begin mode on our calculator, and then we can start programming in some of our parameters. We'll take 20 for N, 6.25 will be our interest rate, and going into our submenu here, we have 4 already programmed in for PY. I just need to update CY to 12. I'm taking 850 positive as the payment size, assuming that the payments are coming to us, and 0 as the future value. So let's compute the principal amount. This should come out to be a negative number because we will have to pay into this annuity in order to receive positive payments. So we get a value of negative $14,719.83. And this means that that annuity costs us, that's the purchase price, $14,719.83. And in step 2, we now need to deal with that deferred period of 3.75 years. So we're going to take our negative $14,719.83, we're going to make that a positive value, we're going to treat that as the future value, and we're going to try to discount this money over that 3.75 years. So I'm going to divide here by 1 plus the interest rate, which is 6.25% monthly, and we just need to figure out the value for N. So how many compounds are we going to have? Let's take our time step, which is 3.75 years, and let's multiply this by 12. That tells us that we should go through 45 compound periods. Performing the indicated division, we should get a final present value of this payment stream to be $11,651.43.